Hello! So in this video, what we're going to be doing is adding animations to these objects. We're going to let them actually be able to move around in the scene, change position. You could have them even change scale or rotate around. And likewise, we're going to have it so that we can actually interact with these objects and make them do things like move around when we click on them and whatnot. So you'll see that first off, what happened is I raised the sphere up into the sky a little bit. That's just because we have our fuse timer on the center of our screen right now, right? That does an automatic click event, and we don't want that going off randomly when we load the scene up before we want it to. So we'll just have our sphere slightly out of the way up in the sky here. And if we come over to our code, you see that all I've changed is just the position of the sphere itself. Everything else is still the same from the last video. So let's talk about what it is to actually add animation. And it's all done through the animation component, actually. Let's make the box spin in like 360 degrees. Let's just make it rotate in circles. And to accomplish that, as you might expect, you add an animation component. And the values you associate with it, the first one being the property. And in this case, property is actually referring to the other properties of the entity itself. So for example, we can set the property to be the rotation. And so now we'll change the rotation over time. What we want to do is actually set the to value to it. So it starts at 0, 0, 0, as we have here. And we actually want to move it to 0, 360, 0. So it's doing a full rotation. The next thing is the easing on it. So the animation component is actually taking your initial value, and you can either default to whatever it currently is, or you can specify a from value if you want to, and the to value, and it's interpolating between those two values over some duration and with some function over time. So that's what the easing is it determines how that value changes over time for the duration of the animation. So for this case, we can just set it to linear, and then we can set the duration, which is just DUR. This is milliseconds again, so we'll set it to 5,000, so it'll last 5 seconds. And the last thing we'll set is if it loops, and this will just set to true. So loop true means that it'll just continuously rotate, repeat the animation every single time. And so just with that, with this animation component added in, we can go back to our scene and see that our cube is now rotating infinitely. It'll just keep doing the same rotation over and over again until either the component is overwritten, the animation component specifically, or you change the animation component in some way. But for the time being, it'll just stay like this. And we, as you remember, have this target marker that we put on it, and you can see that the spheres are actually not moving with the cube. And the reason for that is that every object in 3D space has its own local coordinate system. And so these spheres were added in as a child of the scene, if you remember correctly. And so they're not related to the cube right now. They're actually just being placed in global space at that position, as opposed to the cube. And the cube has its own coordinate space based on the transformations that have changed from the cube to the world space. So like if you change the scale or the position or the rotation of the cube, it now has its own coordinate space that its child objects would exist in. And so we can see what that looks like first off if we change in our target marker script from adding these markers to the scene. We could instead use EL, which is a reference to the entity itself, and attach the markers to that instead. And so if we come back to our application, we can see that it's rotating. And now if we click on it, these spheres are getting added, but they're not added where you expect them to. Because again, the local coordinate space doesn't match the global space. So the position that we're giving into this function is in global coordinates, but that's not in local coordinates where they should be on the box. And so we can change this, we can fix this. This is actually the first time we're going to see, this is an A-frame, this is actually underneath using Three.js. And so for the first time, what we're going to see is that every A-frame entity actually has a reference or multiple to underlying Three.js objects that they represent. And so one of the things that comes with is a function where you can do a transformation of the world coordinate space to the local coordinate space of that specific object. If you're interested in that, there's an entire area that you can look into and learn more about in terms of graphics and transformation matrices and things of that sort. And that's what's actually happening underneath the hood. But for your own knowledge, what you need to know is that we have a reference to EL, or the entity of this component. And EL has a reference to object 3D. And that is actually the reference to the 3JS object underneath in the graphics library that A-Frame is built on. And so this comes with a function called world2local. And world2local accepts a vector. In this case, it's a position, which is XYZ, and it changes that XYZ vector into local coordinate space. So now we're setting these marks, but the position we're setting them to is in the local coordinate space of the cube as opposed to in the global coordinate space. And then we're attaching them to the cube. So now if we come back to our application again, if we click on the cube now, the spheres are actually positioned in the correct location now, as you can see, and they rotate with the cube. So this is something you have to bear in mind when you're trying to do this kind of more complex interactions, is that every one of these objects, it's a blessing and a curse in terms of you have to think about, you can have these objects do much more sophisticated movement if they're child objects of other things. Think about like having a car that drives around with wheels attached to it that then rotate. But sometimes you really have to think about that chain of how everything is hierarchically connected to each other and positioned. And even in this case, you might start seeing weird things happen. Say before we had it set where the target marker would, if you clicked on an existing one, add a new one, but you can see it starts to do some strange things here when you're now trying to change the coordinate space, but it's using the transformation matrix of the cube when it should be using it of the sphere itself. Or rather, it's the reverse of that. And so you start to get this strange behavior occurring where things start to get scaled weird. You have these spheres that appear on the outside. So this is where it can get kind of dangerous, but also you can do some really interesting things with it. And that's where if you're interested in this, you really have to dive into it some more. So that's just one example of using the animation component and also about looking at this coordinate space hierarchy a little bit. And now we're going to look at what if you want to have kind of more dynamic animations, right? That's just kind of a default rotation. If you want to have like something move, if you defined it in the HTML itself, it would only do that animation once and it would only be able to loop from there. But let's say you want to have a new animation that actually moves an object from its current position wherever that is. And so we're going to make a new script for that. And we're going to call this one mover.js. And following the syntax of before, we're going to do aframe.register component. We're going to call this mover, and then we're going to have our massive JavaScript object created here and follow the same expectations we had before. So we've got our init function, and we'll capture a reference to the entity that this component is on as usual. And we're doing this because once you enter into the function space, your this reference changes. So you need to have an actual reference to the entity once the context of this changes. And in this case, we'll call it this.animateMove function. And then we'll open that up. And for this animation, what we want to do is have it move from its current position to some other place that's a set distance away. So this is actually the first time we've seen this, but we're going to define a new variable called current position, and then we're going to do EL and then get attribute. So much like set attribute, you could also do get attribute to capture that data. And in this case, we're going to use get attribute position. So there's only one parameter you pass in for this. It's just whatever attribute you're trying to capture. So that could be a component or a property associated with the entity. And then the next thing we're going to do is define an object of parameters, because as we saw with the animation component, there's quite a bit to specify. So in this case, we're going to define our own kind of organized JavaScript object, and then we'll pass that into the event listener later. Or into the attribute details later, instead of having to define it all in one line of code. So in this case, we'll have, much like we saw with the other component, we have our property. In this case, we're setting it to position. We then have our to value, which is its own JavaScript object. In this case, it's got X, Y, and Z. So we will use current position.x, and let's move it 5 units in the X direction. -5 off of X. And then we have our Y. Let's keep our Y position the same. So we'll just capture that same value there, fix that minor typo. and then our Z, and that will be current position dot Z, and we'll leave that the same as well. We'll just have it move in one axis in 5 units away. And that's our to value. And then we have our duration, or DUR, and we'll set that to 5,000, 5 seconds again. And this time, just to make things a little interesting, instead of having a linear easing, we'll use one of the more interesting ones that's called ease in out elastic. And if you want context on this easing, there is a documentation on the A-Frame website about the different types of easings that are available. You can look at them and kind of experiment. There's also like quadratic and things of that kind to do different types of different interpolations of an animation. And so we've got all of our parameters defined here. And the last thing we'll do is el.setAttribute animation, and then we'll pass in our params. And that's our animate move function. And so now we will have our event listener defined. And we're just going to keep listening for the click event in this case. We'll pass in this .animate move. And we'll also specify our remove function. And this will be quite simple. Again, this will just be this .el.remove event listener. And we're grabbing click again, and this .animate move. And we'll fix that minor typo, say add event listener, not just says event listener on that. Remove event listener, click animate move. So this should be everything. And so now we can come back to our index file again, and always remember to actually include the script at the top of your file. So this one's called mover.js. Close that script off, and we can attach it to our sphere. So it's called mover. That's the name of the component. So we can attach it to our sphere right there. And assuming everything worked, we can come to our scene again, which is just reloaded. And if we click on the sphere, you see it wobbles back and forth, and then it moves off to the left. And because of the way we've defined this, if we click on it again, it's always taking its current position to do the animation from. So it will continue to move in this direction every time you do this. And it'll continuously move off in the distance. And one thing important to note about this is that the animation component can be overwritten at any given time. So I can click on the sphere right now, and then mid-animation click on it again, and it will reset the animation component, because you can only have one version of the animation component on an object at a time. There's ways to have multiple animations at the same time, but it's a specific syntax you have to specify, where you have to use an underscore followed by a number for each animation. So if you're just defining a basic animation component to attach to it, it will continuously overwrite the prior one. So every time I click on it, it'll reset the animation over and over again. But otherwise, it's always taking the current position of the object that it starts the animation from. And in this way, you can have this do dynamic things like move away from you or move in certain directions. You could take the angle of the difference between the current position of the camera and the position of the sphere and have it move away or move towards you when you click on it or things like that. It's all just a matter of going into your script and capturing different data. You could, in the mover, you could use your scene query again or things of that sort to go capture other entities in the scene and then use that data from those entities to do something specific or dynamic with this function. So that's everything that we need to cover for the animation component. In the next video, we're going to talk about creating custom events and do something a little more complex with the animation component.